Hi everyone, in today's video I want to test out 3 of the highest performing AI models in the market right now, namely ChatGPT, Deepseek and Grok 3. Apart from that, I'm also going to test out some of my local models that completely run offline on my computer. And in a moment I'm going to share with you what those models are, what my parameters are, and what prompt that I'm using to test it out. So in relation with the prompt, I'm using a spinning hexagon, or it's essentially like a polygon spinning with different colors of balls inside. And we're asking each AI to write out a Python code that simulates how the motion of the balls follow in a spinning polygon. And the advantages of this prompt is that not only does it allow us to see how AI writes the code, it also shows us how it reasons within a physics setting. So the AI not only has to know how to essentially write a code and follow our instructions, but also understand how that simulation is going to simulate an environment on Earth, which we tested. So it's essentially like a simulation that we're trying to get the AI to do. And so the AI has to understand from a human mind or from a human perspective how things in the world works. And this assesses both the coding and physics abilities, but also maths, of course. So let's get started. Okay, so as you can see now, we have ChatGPT, Deepseek, and Grok, 3 of the strongest AIs in the market right now open on the screen. And I'll be pasting the same prompts to all 3 of the chatbots and see how they respond. So in the tools here, I'm gonna write think for longer, because we need a more powerful model to be employed here for ChatGPT to reason it out. So the prompt here is very simple. So we're asking the AI to write a Python program that displays multiple balls bouncing inside multiple spinning polygons with collision against the borders, and blah, blah, blah. Actually, I copied this prompt from Anthropic. So Anthropic, a few months ago, had a video where one of the engineers used this prompt to test its own AI model. And I think that prompt really captured the essence of what AI could do. So that's why I borrowed the prompt to test the AI here. So essentially, those rules are instructions given to the AI and will later verify if the product produced by the AI matches our instructions or not, and whether the collisions and the rotations of the polygons follow the physics of our world. Now I'm gonna click run actually and wait for it to finish, and then now we're heading to Deepseek, pasting the same prompt in here. So because this is the same prompt, it is what we call a control variable. So we're trying to be quite sciencey here. So now I'm going to click on the Deepseek R1. So it's the reasoning model of Deepseek, and let's see how it goes. And then here is Grok. For those who don't know what Grok is, it is an AI model developed by Elon Musk and part of XAI. In my opinion, Grok is probably one of the best performing free tier closed source AI models out there, based on my personal usage, but let's see if that's true. So we're gonna click on think as well. So click send, and we'll wait until the AIs have completed everything, and then we'll export that to a Python file and start running. In addition to testing out the large closed models, large language models online, I'm also going to test out some of the small open source models that are available. So as you can see here, the Wi-Fi is turned off, so everything that I run is completely on my Mac. The Mac I have is MacBook Air M2 chip with 16 gigs of RAM. So let's get Ollama start running. So Ollama list. Let's see what models we have. We're going to try the Phi-4 mini reasoning. It's quite a small size model that can even run on your phone, although we don't know how to install that yet, but let's just try that out. So Ollama run this. And now the model will start to initialize, meaning that it would get started, and then we'd have the opportunity to ask it some messages. Oh, oops. I'm gonna go copy and paste the prompt that I initially had. So I'm gonna scroll down here, copy the prompt, and then come back. Ooh. It's taking a bit of time. It's loading. I've clicked the paste, but the message is still loading. So after we put this in, we click enter, and this model will start thinking. So because this is a reasoning model, it essentially writes out everything that it thinks, just like a human. So after a few minutes, I will come back and test it out. Okay, so the local AI keeps on failing because it just keeps on generating tokens, generating the reasoning code, but doesn't move on to write the actual code. So I have to terminate that. So now let's go back to the three online AIs that we've tested and see what their results are. Let's go. Here we go. So we have the bouncing balls polygons, as you can see, and we'll copy that and then go to Visual Studio Code, paste that in, go to deepseek.py, so that's the code, copy it in. Perfect, and then go to Grok online, so it's this one here. Copy the code and move that to Visual Studio Code. And then we should be able to run those three and see how they compare with each other. Okay, so let's have a look at what the code generated by ChatGPT looks like when it's run on my computer. So as you can see here, let me move the window like that. It's very strange the way particles are moving here. So let's first look at the spinning triangle here. First of all, I don't think the spinning triangle with one particle inside has any anomalous movement here. It pretty much follows what the physical world looks like. The second particle as well looks okay, reasonably fine, but there's a issue here because in the prompt it says you need to have essentially n-2 number of particles in any shape with n sides. So in the case of triangle, the triangle has 3 sides, so 3 minus 2 is 1, so you only have 1 ball. But in this case, in the square, you're supposed to have 2 balls here because a square, as we know, has 4 sides, so 4 minus 2 is 2. So it should have 2 balls inside the square, but it doesn't. So effectively we know that here ChatGPT didn't really follow the instruction that well. And the same thing can be said for the pentagon as well, which should have three sides, should have three particles, not two particles. And if we ignore those discrepancies, let's focus on the movement of the particles. Do you guys think it's something we would expect in real life? I don't think so. I mean, just look at the way the particles reflect off the surfaces. It looks very artificial to me and doesn't really follow that much of a physical law, especially focus on those particles in the what would you call it, octahedral here, octahedron, sorry, the 8-sided shape. The particles seem to be attracting each other, if you understand what I mean. So normally, when you think about elastic particles, right, they would bounce off each other when being collided against each other. But here, we can notice that apart from just one particle here to the left, the blue particle, all the other particles seem to be bonded together. And there seems to be an artificial force of attraction between those particles, which is very weird and doesn't really follow the logical sense of physics. So I wouldn't really say ChatGPT has coded the polygon window very well. And if I was a human, well, I am a human, but if I was someone checking this code, I would immediately have red flags all over the place, because ChatGPT, let's face it, doesn't really understand how our physical world actually works. Now, let's have a look at Deepseek. All right. So this is Deepseek's window. So in stark contrast to the code generated by ChatGPT, we can see here that in Deepseek, the polygons don't really move. And in terms of instruction following, I would actually say Deepseek has done a slightly better job here, because look at the number of particles that we asked for. The particles we asked for is n minus 2, n being the number of sides of the polygon. So here, the triangle should have 1 particle, square should have 2, pentagon should have 3, hexagon should have 4, and it followed the instruction pretty well. But here again, the motion of the particle seems a bit stilted if you look at a multiple particle scenario here, or there, or the 10-sided particle. But on an overall impression, I would actually say ChatGPT didn't do a job as well as Deepseek has done. Because on one level, in ChatGPT, the shrinking and expansion of the polygons, which we hadn't asked for, was more prominent. So ChatGPT has a more prominent hallucination. And the other factor here is instruction following, because in ChatGPT, obviously the large language model didn't follow our instructions of the number of particles that well as Deepseek. So that's a huge minus for ChatGPT there. There's a huge amount of hallucination. And then thirdly, on an overall movement here, I think both AI models didn't do the job that they were supposed to do. For example, here in Deepseek, we see that this pentagon is just expanding, shrinking, expanding, and shrinking. It's not actually rotating as we've instructed to do. So at this stage, I would say both ChatGPT and Deepseek suffer quite a lot from hallucination, misfollowing our instructions, and also not having a comprehensive understanding of the physical setting. Because obviously it hadn't taken into account of the effects of gravity that well. But I would say on balance, that Deepseek has performed slightly better, only slightly better than ChatGPT in terms of both understanding the physical world and also following our instructions well. And you might be asking why I didn't test out Grok. Well, because there are quite a lot of bugs in Grok. Lots and lots of them. So I didn't bother testing out Grok at this stage, but we'll do that in the next few videos if you'd like. So in conclusion, in this video, we've discussed 3 of the best performing AI models out there for ordinary users to experiment with, and we've tested all 3 of them with a very simple Python generating code based on physical environment setting. And what we've concluded is that both ChatGPT and Deepseek struggle quite a lot with hallucination and also instruction following. But overall, Deepseek performed very slightly better than ChatGPT in terms of instruction following. But Grok, on the other hand, although I personally thought it was a better AI model, it did not satisfactorily create a program that we can run without debugging. So that will be left to the next video potentially. And let me know what you think in the comments below, and I'll catch you next time.